welcome to Towhid Academy. Today we are going to solve Theorem 1 of Group C Geometry of Class 8. Theorems of our book are in chapter 8, 9 and 10. Exercise 8.1 is for theorem and exercise 8.2 is for construction. So there are a total of 5 theorems in chapter 8. So let's get started by doing theorem 1. This is the general enunciation of theorem 1, and now we are going to draw the figure. Let me show you the figure. This is the figure of theorem 1 and this is the total theorem, but we are going to give it a little change because we don't need to write all of the things in our book. So let's get started by drawing this picture. We do not have to draw the exact quadrilateral shown in our book. We can draw any quadrilateral, but there must be a diagonal between in the quadrilateral, which will divide it into 2 parts. So let's draw. Draw. The diagonal which will divide the quadrilateral into 2 parts. Now A, B, C and D. Now we will write proposition or particular enunciation, whatever you say, both are correct. So let's write proposition. Or particular enunciation. You don't need to write both of it, you can write any one. Particular, LBCU. Now, let A, B, C, D be, let A, B, C, D be a quadrilateral. It is required to prove that angle A plus angle B plus angle C plus angle D equal to 4 right angles. The sum of 4 angles of a quadrilateral equal to 4 right angles. So we will write it in this way. It is required to prove that angle A plus angle B plus angle C plus angle D equal to 4 right angles. It is not necessary to write construction in every theorem, but as we have drawn a diagonal in the quadrilateral, we have to write construction. But we don't need to write all of the things in book. We just have to write the first line, join A and C. The diagonal AC divides the quadrilateral into 2 triangles, triangle ABC and triangle ADC. This line is not necessary. We just need to write construction, then construction. Join A and C. We will, as we all know, we will get only 21.6 minutes in each of the in solving each of the creatives. So we must be conscious that we are not wasting time unnecessarily. So we are not going to write too much which are not that much necessary. We will write only the important points and only the points which are really significant for this. So proof. Now we are going to write, we are not going to write these two justifications. We are just going to write on the top, we know that the sum of three angles of a triangle is two right angles. We know that, then this portion. We don't need to write in this every time. As I've already said that we have a really less time and it takes more in geometry. So we are just going to make it a bit short. We know that. The sum of three angles of the triangle is two right angles. And that's it. Now we will move to our real points, which are these. We're not going to write step 1 or step 2. We will make it a bit easier. So in triangle ABC. So we are going to prove this triangle first. In triangle ABC, angle BSC, which is this angle BSC plus at first let's write angle BSC plus angle B. This is a whole angle, so we don't need to write angle ABC. But if you want to write angle ABC, then it's correct. So angle B plus, it's on your choice, you can write any of these. Then angle B plus angle ACB equal to two right angles. As we already know, the sum of three angles of a triangle is two right angles. Two right angles. So we have already proved this part of the triangle, and now the rest part, triangle ADC. We have to prove this one now. So we will write similarly. In triangle ADC, this one, triangle ADC, at first angle DSC, that means this angle. So at first angle DAC plus angle D, which is a whole angle like the one of angle B. So angle D plus angle DS plus angle DSC. DCA plus angle DCA. So now DCA equal to two right angles. Now we have shown that you have to write you have to give equation 1 and equation 2 in these. It will be easy for us to add. As we are not putting steps, we have to write equation 1 and equation 2. So we have shown the two triangles of the quadrilateral, which we have divided by the diagonal, and then we are going to write now by adding equation 1 and 2, we will add equation 1 and equation 2 for getting the summation. So let's start. Angle BAC, which is this angle BAC, this one. I may point it in a different way so that it must be clear to you. Plus angle DAC, which is this. I've already marked it, DAC, this one. Let me do it again. So this one. Now plus angle DAC. So this gun, and now plus angle B, which is this one. It's a whole angle, so we don't need to write anything. This one, bit different way. You don't need to do this point or this point, or you don't need to give two arcs and arcs or radius in it. You just have to give one arc or radius in your exam copy, but I'm just doing it for making it a bit much clearer to you. Then plus angle ACB, this one, angle AC, it's angle ACB, so this one, point. We have proved this 3, and plus angle ACB. Now the last, no, not the last, the second last, then which is angle ACD, so this one, we're going to put 2 arcs in it, angle plus angle ACD. Now the last the whole and one of the whole angle ADC, or I have it written over here, or angle D, because it's a whole angle. We don't need to write ADC, but if you want, then you can. Equal to 2 plus 2 or 4 right angles, RIGHT angles. Now we will convert this 2 into angle A. Now let me show. BAC, this one, and DAC, this one. So this plus this. Now it will turn into a whole. Okay? You don't need to give this radius even. You just need to give 2 different radius, or you can be free. You don't need to give any radius because your book doesn't show that. So the whole, we will appoint this whole into angle A, then plus angle B from here, then plus angle ACB plus angle ACD, which will be angle C, angle ACB plus this one, and then angle ACD, which is this one. So this one and this one will be angle C. Angle C plus the whole one. Where did we go? Angle D, equal to 4 right angles. So it's already proven without any justification. It must be too easy for you now, even if you couldn't understand it before. So this is the answer. So we can give this mark over here. Now all we need to do is write proved over here, and this theorem is totally solved. So please share, like, and give a comment below, and don't forget to subscribe. And thanks for staying with us till the last of the video.